it's a non-square system, so we're going to have, hold on. So we have a non-square system, which means like a square would imply there's the same number of equations as variables, so it's kind of like a rectangular system. So we're going to have an infinite amount of solutions here. So we want to get everything in terms of one of the variables. So since we already have this bottom equation where you have 4x minus z equals 0, we could get z in terms of x by just adding z to both sides. So we have 4x is equal to z. So if we were to like write out our system of if we were to write out our solutions, like if that's x and that's y and that's z, we can leave x as x, we can leave y as y for now, but since z is equal to 4x, we could plug in 4x in for z. So now we know like whatever x is, z is going to be 4 times that. Alright, so now we could take this and plug in, we already have x in for x, we could plug in 4x in for z, and then get y in terms of x. So now I'm going to take that top equation, and x stays as x, minus 2y plus 5 times z. Well, z is equal to 4x. Oh man, having technical difficulties here. Plus, come on. Sorry, it's not writing. 5 times 4x equals 2. Alright, so then we get x minus 2y plus 20x is equal to 2. Alright, that's a 2. I gotta make sure I write it like a 2. So then I get 21x minus 2y is equal to 2. Alright, negative 2y is equal to 2 minus 21x. And then divide everything by negative 2. And we get y is equal to negative 1 plus 21x over 2. Alright, so now we have y in terms of x. Alright, so then we could plug that in right there, and that would be our solution if everything was in terms of x. Alright, now I'm going to look at the answer in the back of the textbook and see what did they, like, which variable did they put these answers in. Okay, so on the left is the answer that we just got, and on the right is what the back of the book says. So the back of the book is always going to put this in terms of an independent variable. So a represents like any real number. Alright, and both what I have in like purple and red, they both represent the same set of solutions. Alright, and here's how. Alright, if you let x equal 2a, right, and you plug in 2a in for x, alright, you get 2a, and then negative 1 plus 21 times 2a divided by 12, which would be 21a, and then plug in 2a in for x there, and you get 8a. Alright, so this is the same answer. It's just writing it in terms of like an independent variable instead of picking x, y, or z. So if you're ever not sure if your answer is the same as like the one on the answer key, like look for whichever variable you put everything in terms of. So in my case it was x, and then look at how they represented that variable. Alright, so we got x equal to 2a, and then plug 2a in for x everywhere else that you see it. Alright, another way to check it would be like to take a number, like so like let x equal 0. Alright, so if you plug in 0 in for x, you get 0, negative 1, 0. Alright, so that represents like one order triple that satisfies the system. Alright, well, you would also plug in 0 for a to make this first term equal 0. So you'd get 0, comma, negative 1, comma, 0. So although that's not proving that these are the same answers, it shows that the same point is on both of these sets. So they're probably the same answers. Alright, but there's a lot of ways you can express these, and that's why it gets confusing, but you're probably doing it right. So try to rewrite both of them in the same way, like I did down here, if you're not sure if you're doing it right.